So this is the second part of section 5.1. It's a little bit of a bag of tricks that you're building. So you're learning all different ways that you can solve these, and oftentimes there's more than one correct way to solve them. There's easier ways, there's harder ways. So if you see a few examples of doing it in various situations, then when you get to do them on your own, a couple ideas might pop forward. So look at number 8, right? A couple more examples. I got 1 plus sine, and I got a secant minus tangent. I got a couple options. Why don't I try foiling this out? So 1 times secant is secant, so I get secant x. And then 1 times negative tan is negative tan. Sine times secant gives me sine x. Well, secant is 1 over cosine. And then at the end, sine times tan. Tan is sine over cosine. What does that give me? Well, it gives me secant x minus tan x. Sine over cosine is tan x, so I get plus tan x. And then sine over cosine gives me minus sine squared x over cosine x. Well, look at this. The minus tan and the plus tan go away. So I'm left with secant x. Well, secant is 1 over cosine, so I'm left with 1 over cosine x minus sine squared x over cosine x. And look, the way we set it up, common denominator. So I got a 1 minus sine squared x over cosine x, right? If I combine them together, the cosines remain the same. On the top, I got a 1 minus sine squared. So 1 minus sine squared over cosine. What am I left with? Well, if sine squared plus cosine squared equals 1, then 1 minus sine squared is cosine squared. So I got a cosine squared on the top. I got a cosine on the bottom, which gives me cosine x. And now it matches up with that. If I had more space, I would just run it all the way down, but I didn't, so I'm squeezing it in a little bit. All right, look at the one underneath it. 2 tan secant equals 1 over 1 minus sine minus 1 over 1 plus sine. So I have a couple of options. I can work on the left-hand side to try to make it look like the right-hand side, or I think it's probably easier to see if I can do something with those two separate fractions on the right-hand side and see if I can combine them. So let me switch boards because there's no way I'm going to fit the whole process on here. I'll see if I can simplify the right-hand side and then bring it back. All right, so from the other screen, we had a 1 over 1 minus sine x minus 1 over 1 plus sine x. And I would like to combine those into a common denominator. Well, the common denominator looks like it's going to be 1 minus sine, 1 plus sine. So here, let's multiply top and bottom here by 1 plus the sine of x. And let's multiply top and bottom here by 1 minus sine x. So I end up with a 1 plus the sine of x over, if I look at that denominator, let's multiply them together. 1 times 1 is 1, minus sine plus sine goes away, sine times negative sine squared, minus 1 minus sine x, and when we multiply these together, we better get the same thing, right? 1 times 1 is 1, minus sine plus sine goes away, sine x times negative sine squared x. Well, 1 minus sine squared x is cosine squared x, right? Remember, if sine squared plus cosine squared equals 1, if I subtract the sine squared from both sides, I get cosine squared equals 1 minus sine squared. So let's replace these things on the bottom here with cosine squared. So I get 1 plus sine x over cosine squared x minus 1 minus sine x over cosine squared x. Now, remember that everything in the second piece is in a set of parentheses. So you got to distribute that negative sign to both parts. So combine them all over cosine squared x. And this gives me 1 plus sine x minus 1 minus minus sine x, which is plus sine x. And so 1 minus 1 is 0. Sine plus sine is 2 sine. So I get 2 sine x over cosine squared x. Right, so make sure all of this makes sense here. Right? I took my original problem, hit top and bottom with the same thing here, same thing here. So I'm multiplying basically by 1. And then I was able to create common denominators, combine everything together. I turned the 1 minus sine squared into a cosine squared because it seemed like a good thing to do to help simplify a little bit. And I have an expression 2 sine over cosine squared. All right, let's go back to the problem and see how that helps me. We said now this right-hand side here becomes 2 sine x over cosine squared x. Well, it's looking good so far. There's a 2 involved. Let's take this and separate it. So rather than cosine squared, let's think of cosine squared as cosine times cosine. On the top, let's think of sine of x as sine of x times 1. My 2 just carries over. So I get 2 sine over cosine is tangent, 1 over cosine is secant, and look, that's exactly what I'm looking for. 2 tan x secant x. Right-hand side, left-hand side matches up. So I guess it's worth mentioning, how did I know to do the problem this way? Well, first of all, I've done these a few times, and then also I thought about it a little bit before I went to record this. So the first few times you do this, the answers may not jump out at you. You may try a couple of different ways and run down roads that don't lead anywhere and take your eraser and go back and try it again. So just because I'm flying through these and saying, hey, look, here's a great idea, it will take you a little bit of practice before you get there. It may be frustrating at first because you try something and it doesn't work, and you try something else and it doesn't work, or you make a mistake along the way. But after you've done this a few times, maybe then it'll get a little bit easier and you stumble more quickly upon a solution that works. All right, let's look at this one. Now, this one has 2 options, right? One of them is to take the left-hand side and maybe multiply top and bottom by 1 plus sine x with the hopes of creating a 1 minus sine squared on the bottom. The other one is to look at the right-hand side and try to turn that all into sines and cosines and see if that will help simplify. And then the other option, too, is we could take out a secant and end up with 1 plus tan, but I don't know if that's going to work so well. Well, I mean, it might. We could try it, right? Take a secant out of everything, and you end up with a secant x. You're left with another secant over here and a tan. So secant is 1 over cosine of x. Tangent is sine over cosine. And now combine those together, and you get secant x times 1 plus sine x over cosine x. But this secant x over here is really 1 over cosine of x. So just for space-saving purposes, I'm going to rewrite this as 1 over cosine x. So when I do that, multiply across the top, 1 times 1 plus sine x is obviously 1 plus sine x. On the bottom, cosine x times cosine x is cosine squared x. Well, that doesn't look like it's what I'm looking for, except that, again, if you remember that sine squared x plus cosine squared x equals 1, that means that cosine squared is 1 minus sine squared. So I'm just going to move across because I'm out of space the other way. So I get a 1 plus sine x over, instead of cosine squared, I'll write 1 minus sine squared x. And then from this stage, you got 2 options. One of them is to keep going and factor the bottom as a difference of squares. So in the top, you got a 1 plus sine of x. On the bottom, you get 1 plus sine of x, 1 minus sine of x. All right, foil them back together if you don't believe it. You get back 1 minus sine squared. And then, of course, these 2 things go away, and you're left with 1 over 1 minus sine x. The other thing that you might have done at that stage is multiply top and bottom by 1 plus sine x. And if you did that, if you multiplied top by 1 plus sine of x and the bottom by 1 plus sine of x, you would have gotten to this stage over here where you have 1 plus sine over 1 minus sine squared, and that's perfectly fine. That's working both sides of the equal sign separately until you get the terms to match on both sides. So you can do it that way. You just don't want to cross the equal sign if you don't have to. So you can work your way all the way through until you've simplified it completely and you get a 1 over 1 minus sine, or get yourself to the point where you have the terms circled and then match them up on the other side. All right, last one for this section. This says verify do not cross the equal sign. The temptation here is to try to cross the equal sign because if you cross multiply, the problem solves itself very quickly. But for sort of accuracy's sake, we're going to try not to cross the equal sign. So one option that I have is to multiply top and bottom here by 1 minus cosine x. I'm going to do it this way because I have a little bit more space here. So let's multiply top and bottom here by 1 minus cosine x. So this gives me what? On the top, it gives me the sine of x times 1 minus cosine x. On the bottom, 1 times 1 is 1. When you FOIL it, you get minus cosine plus cosine, so that goes away, minus cosine squared x. All right, well, if sine squared plus cosine squared equals 1, then 1 minus cosine squared is equal to sine squared. So I get a sine of x times 1 minus cosine x over, let's turn that 1 minus cosine squared into sine squared. And one of the signs will cancel top and bottom. So this sign here, one of those signs there, until I'm left with 1 minus cosine of x over the sine of x, and that's exactly what I have on the other side. We could have done it the other way by multiplying the left side by 1 plus cosine x top and bottom and worked our way till we got the right-hand side. And that's the basic idea of all of these verify problems. What's going to happen in the next couple of sections is simply I'm going to introduce more formulas. We'll work through some of those formulas, and then we'll work through some identities with those formulas. But once you have the basic idea, the other ones follow a similar pattern, but just with different formulas.